Okay, this is a supplemental lecture on file systems. The reason I made this is I want to make sure you have a good understanding of file systems and some related topics. It seems that in some cases students make it through CIT 111 and or CYS 145 where they should have learned this and for whatever reason do not have a good understanding of them. So first off, what is a file system? A file system is how an operating system organizes, stores, and retrieves objects. Most modern file systems are hierarchical in nature, which means they have directories, and that directory can contain multiple files, and a file system object belongs to a single directory. And a lot of times people say it looks like an upside down tree. So let's look at an example of a portion of a file system. This is from a Unix machine, or at least a representation of a Unix machine, because the very top directory is referred to as root or sometimes slash. So slash is a directory, and it probably has many things, files and folders, but I've chosen to show 4 directories. Now, the legend for this is anything that's in an oval is a file, and anything that is in a rectangle is a directory. So I'm showing 4 directories: user, sbin, home, and bin. And within the home directory, I'm showing wbeach0001, my user ID. And then within there, I have a CIT 144 directory that contains multiple files, 2 of which I've shown you here. So this is a representation of a modern hierarchical file system. Now, I said file system objects. So what are some of the file system objects we might have? So I'll start with the Unix file system. We have files. Files are things that hold information. So it might be a text file, it might be a Word document, it might be an Excel spreadsheet, might be a text file, might be an image, lots of different things might be stored in a file. Now, directories are file system objects that can hold other file system objects. And files and directories are things that, I'm sure everybody's very aware of. Now, some other file system types that Unix has, for starters, is symbolic links, sometimes called symlinks. And this is when you access a file on the Unix file system, and if it's a symbolic link, it has a path to where the file really is, or where you're going to get the data from. We also have something called hard links, and what a hard link is a situation where you have a file or a file system object that has data in it, and you allow it to have multiple paths to reach that file. If there are 5 hard links to a file and you delete one, it will keep count and know that there's now 4 hard links. If the hard link count ever gets to 0, then the actual file system object is deleted at that point. We also have device files, which allow us to communicate with devices. So that might be a printer, it might be a hard drive, it might be a TTY, which is a login connection typically. It can be a lot of different things. Then we have pipes. Pipes are a construct that allow us to send data in the pipe, and then it travels down the pipe out the other end. And at the 2 ends of the pipes, you have programs running. So the output of one program goes down the pipe and becomes input for the next program. We'll have a lecture on I/O redirection that talks a lot more about pipes. Sockets are endpoints of communications, much like we refer to sockets in, the Cisco networking classes. Now, on Windows, again, the two that you're most familiar with and that every file system has is files and directories. Windows also has symbolic links. Windows also has hard links. Over time, they've just happened to make Windows behave, especially the kernel and the underpinnings, more like Unix. We have junction points, and basically a junction point redirects one directory to another. Windows has pipes as well, and it has device files as well. So those are file system structure and objects. The next thing that we need to be aware of is path names. And basically a path name explains how to traverse a file system tree to get to a file system object. And there are two types of paths. The first is an absolute path name. That is where we start at the very top of the tree and tell step by step every directory to pass through to get to whatever file system object we want. Now, that's slash for Unix, and it's a drive letter for Windows. So like for Windows, you might say // and you specify the directory path from the drive letter. The other type is relative path names, and here you specify how to reach the desired file system object relative to the current directory. So let's look at some examples. So here's an example of an absolute path name in Unix. So /user/local/bin, or to a file might be /user/local/bin/log-to-timeline.py. Maybe it's an absolute path to my home directory, which is /home/wbeach0001. So those are absolute path name examples for Unix. Now for Windows, it might be /users/wayne, or /Windows, or maybe we want to run windump by giving the full path name. So /program files /windump/windump.exe would execute windump.exe as long as that file exists. Now there are some special cases for file names, and these special cases I believe are all going to be relative path names. The first is a Unix own thing, which is ~user ID. And basically what that does is it looks up in the password file to find out where your home directory is, and then traverses the path relative to the user ID's home directory. So an example might be ~wayne/python. So on the machine, it would go to /home/wayne/python, for example, if my home directory was in /home. Another special case is period. Period refers to the current directory. So an example in Unix of using this might be in the current directory, go down into a directory called Python and run pgm1.py. Now another example for Windows is, let's assume we're actually in the directory where windump is installed. So we might say in the current directory execute windump.exe. So the /windump.exe as shown here. Another special case is .. which refers to the parent directory, which is the directory, one directory up from wherever I currently am in the file system. So an example of that might be ... // In the case of Windows, it might be sideways to me. I have a directory called classes. So I want to go up a directory and then down into classes. Now, there are some commands that you should know through the CLI for moving around and doing things to file system objects. So I have a little table here that I'm going to give the concept of what I want to do, and then I will tell you how to accomplish that in Unix, in the Windows command prompt, and in Windows, well, PowerShell. PowerShell actually runs on the Mac. I use it quite a bit. So I want to know what my current location is on the file system. In Unix, it's PWD, which stands for Print Working Directory. Now, there's no Windows CLI command that does this directly, but if you issue the dir command, in addition to giving you a directory listing, it will tell you what directory it's giving the file listing for. So you can get it from the dir command. And in the case of PowerShell, it's get-location. Now, if I want to see all the files that are in a directory, in Unix I use the ls command, which stands for list. In Windows I use the dir command, which I just talked about. And in the case of PowerShell, you use get child item. Now, if you want to move around the file system and change directories, in Unix you use the cd command, which stands for change directory. Same thing in Windows CLI, and in PowerShell it's set-location. Now, one thing I want to mention is if there's a Windows CLI command to accomplish something, like in the example I'm talking about now, the cd command, you can actually use that in PowerShell as well. If you want to create a directory, it's makedir, mkdir on Unix. In Windows, they have the makedir command, but they also have a shortened version, which is md. And for PowerShell, new-item type directory is how you create a directory. If you want to delete a directory, it's rmdir, both in Unix and the Windows CLI, which stands for remove directory. In PowerShell, you use the remove-item command. If you want to delete a file, in Unix it's rm for remove. In the command prompt, it's del for delete. And in PowerShell, it's remove-item. Next thing is we want to display the contents of a file. In Unix, it is the cat command, which comes from a shortened version of the word concatenate. So if you have multiple files, the cat command will concatenate them together and then display them to the user. If you do a cat of one file, then it just displays the contents of that one file. In Windows CLI, you type out the contents with the type command, and in PowerShell, it's get-content. You may want to copy a file, and to copy a file and make a copy of it somewhere else, you can use the cp command, which is a shortened version or abbreviation for the word copy in Unix. In Windows, it is the word copy spelled out. And in PowerShell, it's copy-item. Now, the last one that I'm going to mention now is move a file. In the case of Unix, it's mv, and what it does is it takes the file from where the directory it currently resides in and moves it to another directory, and it no longer exists in the original directory. Now, in the case of Windows, you can use the move command or the rename command, depending on exactly what you're trying to accomplish. And in the case of PowerShell, it is move-item. Now, executing commands, oftentimes students have trouble with this, mainly because they may not be aware of how Windows finds and executes programs. So in Windows and Unix, you have something called a path environment variable. And you either need to have the command located in the directory that's in your path variable, or you need to add it to your path variable, either for the current session or permanently, or you can just give the path to the command. So let's look at Unix first. So to view the path variable, you say echo $path. And the example output might look like this. So what happens is, let's say I issue a command called ABC. It'll look and see if it exists in opt local bin. If it does, it will execute it. If it doesn't, then it will go to opt local sbin, find it. If it finds it, execute it. It'll go through all those paths running the first copy it finds. Now, if it goes through all these directories and does not find the command ABC, then you'll get an error message, something like ABC file not found. Now, if we want to add a directory to the existing path, we can do this. We can use the set environment command to set the variable path. And what I'm setting the variable to is whatever is currently in the path variable. And then I would like to add /new/dir/bin to the execution path. Now in Windows, somewhat similar. However, instead of $path, it's going to be %path%. And if I echo that out, it's going to look like this. So first look in System32. If you don't find it, then look in the Windows directory, then look in WBEM directory, and then finally program files /get/bin. And just like Unix, if it finds the file in one of these directories, it will execute it. If it does not find it, then you'll get a command not found error. You can add things to the Windows path just like you do Unix, and you can say set my path variable to whatever is currently in path, and then I want to add a directory called C:\tools. So if you want to make this permanent, then on Unix you would need to edit either .profile, .login, or your shell's run control file and put the command in there. On Windows, you can edit the registry, or in my opinion, easier, you can go to this PC, Properties, Advanced System Settings, Environment Variables, and then change the path there. And those will make the change to your path permanent. So that is a brief discussion on file systems and related concepts.